I'm Álvaro. As the guide showed me, I am talking about the price of scalability in blockchain. We will see why decentralization could be an issue. So I'm Álvaro. I'm working on Fortress in a R&D department. I have been working for over 10 years in a video game industry, making scalable resilient services in order to provide thousands of concurrent users. It's a high demand industry. And 6 years ago, I was starting to interest in the cybersecurity domain and decentralized technology. That's why I started to study. I'm making research by myself, and I'm here. Okay, what this talks about that? Here we will find where blockchain is in the distributed system ecosystem. Then we will talk about the triangle of balance or trilemma of blockchain. Which one is a paradigm that we use to balance between three concepts: decentralization, security, and scalability. Can help us to make blockchain projects to be more scalable. But there are challenges to achieve that. We will talk about those challenges and how we are resolving them. And then we'll see how decentralization is, how is the paradigm decentralization in terms of peer-to-peer networks. Okay, where is blockchain inside the ecosystem or distributed system? Blockchain is one of the more active projects in the active ecosystem, together with microservices, container orchestrator, serverless computer, each computer. But blockchain have a particular thing. It's a decentralized system. What decentralized mean? Decentralized means that they are not an entity that control everything. So checking that diagram is a diagram from 60 article. Nowadays, this is, I will say that could be wrong, as now centralization is about don't have that control of that entity. Decentralization is about having a mechanism that can provide a consensus. Every node can take control of everything. Why blockchain is a decentralized DDS? Blockchain is a distributed system that is distributed, has all the nodes belongs to the peer-to-peer network, share a copy of information in a distributed way. It's what we call like DLT or distributed ledger. As I mentioned in the last slide, they have a consensus mechanism that avoid to have a central entity to control over the network. There are few components that can say what is blockchain itself. Is the peer-to-peer network of the nodes. The copy of the information on is called distributed ledger. And Bitcoin was the first project born in 2026, and it's an example of blockchain project which brings challenge and some insight we can use to solve the scalability problems from the blockchain projects in general. Okay, right here. No. Okay. Yeah, sorry. Okay. There has been a necessity or requirement from a long time ago. We want to measure the system, looking for tools or mechanisms in order to balance. For example, in a precedent, we had CAP theorem. CAP theorem says that it is a system that only can satisfy two properties, like partition tolerance, availability, and consistency. Here we have a similar paradigms. It's the blockchain trilemma created by Vitalik, the co-founder of Ethereum. In this case, the parameters are not discrete value. I mean, three properties we balance in order to know how this blockchain is accessible for a user experience expectation. There are no discrete value. We can have a project, a secure and decentralized project, and move gradually in order to make this project more scalable possible. So, and nowadays we can find different blockchain problems placed on different places. Has a difference in the CAP theorem. This is being applied to categorized databases, and only can match two of them on a discrete way. And we never will found a project satisfying the three at once. Okay, decentralization. Blockchain is a decentralized technology, secure and decentralized technology that have two pillars. In order to make them more scalable possible, they have to achieve few goals. They have to process in the most high rate possible the transaction per second, and making the average time of processing lower possible in the network in order to achieve the resilience on the system itself. So the common solution that can resolve that are three of them can be found about there. Is dividing the partition in shards or divide the network in shards, and let's say decouple the processing of the transaction. Seizing the data means making the blocks larger and transaction with small pieces, and decouple the transaction processing from the on-chain and moving to another auxiliary structure. But it has a cost in secure overall, and about decentralization, we are making confident on a structure that they are auxiliary. There are extra auxiliary nodes can be controlled by another company, or those nodes can be compromised. For example, for dividing the network into partition of shards, has a disadvantage that in order that they can synchronize the processing between shards, they have to release some information outside, so we are losing on privacy. And for sure, those auxiliary structure can bring some vulnerability, has a different software. Okay, this is a picture that shows how those triangles can be applied in the real life. For example, for the CAP theorem is using for categorized databases. And here we can see the crypto projects, as they are secure and more decentralized and less scalable, are more on those vertices. Ethereum upgrade to improve scalability, moving to this, and Bitcoin to this using the Lightning Network project. And those are permissioning and private blockchain that they don't care about more decentralization. So that's why they are a really great number in scalability. Those numbers depends on the company or brand that requests the services from them. And Steam is a social platform, decentralized. So they are not taking care of the security and honor. Okay, when I say here crypto cruiser, I mean Bitcoin, Ethereum are the active projects in blockchain. As they need to be more decentralized as secure possible, they are critical. Those are the projects had higher problems in terms of scalability. The blockchain crypto suffer the most of the no scalability challenges. They are more secure than the decentralized project. So the goal here is improve the transaction per second. Given this, we can see that the Bitcoin and Ethereum has a low range of TPS between 3 and 10. Let's comparison with Visa 1 is 24,000. Is a big difference, so we need to improve that if we want to compete with a standard project. There are common solutions to fix that. Are not easy. It's just handling the block size of the transaction, partition the network into shards or groups in order to process the workload or transaction separately, and optimizing the consensus mechanisms. One of the challenges in order to achieve scalability are the consensus mechanisms and the incentivization. All these kind of networks have the consensus mechanism, has the confidence in order to decide if the information going to be valid to be in the chain. So it is causing the mass confirm. It's causing the time that is processing in the network. So, for example, when a transaction comes to the network, it's broadcasted and sent to the consensus mechanism. The consensus mechanism can be proof of worker, miners, or proof of stake validators. They are competing, or they are selecting a candidate to choose what transaction going to be added on the block. And then it requires a time of confirmation. So this time can be so high. For example, in Bitcoin could be 10 minutes. So depends on the case of use, could be feasible or not. So we will see into a slide how we can fix that. Another challenge is the data side has a set. Nodes have to store the distributed ledger in a local copy. That's why a full node of Bitcoin needs to save more, around half terabyte. As we have to take care of the data side, it is require more bandwidth, required cost in terms of resources or management. CS is a representation that comparing how this distributed layer is saved on each kind of project. For example, in Bitcoin and Ethereum, they make more fixes to prove that. And each layer and blockchain depends on they are branding projects. So it's not transparent all to see what is the real size. And yeah, how to resolve that? Dividing the network into shards increase the throughput worker processing loader. It parallelizes the transaction processing per shard. They split the networks and delegate the processing in groups, but there are few disadvantages doing this. It is centralization risk. Centralization risk as having different groups. We are isolating groups, so they are easier to be attacked. For example, the 51 attack by manipulation is a no attack that consists in if the malicious attacker takes control over more than the 50% of the network, can manipulate the network. It means they can drop, reject, and avoid new transactions be added on the chain. And handling the size of the block and transaction can increase the throughput. As we are sending more higher information and a smaller unit, we can improve in the processing of the transaction. For example, Bitcoin make an improvement, but from the 1 megabyte, and now it's called Bitcoin Cash in a 32 megabyte. It's a different project. It's like a fork. And since the last proposal improvement, they reduced the transaction size, just decoupled from the original block, but also have some disadvantage. Disadvantage like, okay, we are having more blocker, more layer, and we are having more information to save. We don't need to maintain the same number of the nodes. We have fewer nodes. We have more probability to be attacked. As the block are larger, I need to be sent, and it's more sensible to the DOS attack. Has flooding the system can make the system more sensitive for that. Okay, and the last solution is using offloading the transaction functionality in a different network. They are side chains and other peer-to-peer network that works together with the on-chain and can achieve higher TPS. This is one of the solutions that fix the problem with Bitcoin. Bitcoin is not scalable by design, has a slow rate of TPS, and this incentivization can increase. This last day we have seen that 400,000 transactions has been stuck on the mempool. Mempool is a virtual structure. They are not real. They're just a space that contains the queue of the unconfirmed transaction on each node. You can see just the fee increase has the prioritized transaction with higher fees. So the fees signed before this congestion, they are on queue. Lightning Network born to fix that. Work together with on-chain is a different project, is a different peer-to-peer network. Okay, suppose we want to make bidirectional transactions from a node. A node can make a contract with a specific amount of money and on the on-chain, in blockchain, opening a channel. Once the channel is opening, this user node can send and receive transactions from others, and after a time, he or she can settle the balance into the on-chain. Advantage, we can achieve millions of transactions per second with lower fees, has a great adoption, check the volume capacity of money last. Privacy window has the microtransaction happens in a different off-chain, so they are not recorded on-chain, but we need to maintain this network. Okay, this decentralization is based on peer-to-peer networks. Which one they are distributing the nodes on a physical or virtual network, and they can be under the control of internet providers or cloud providers. We will see that this is a result from front insights of a guy I met in the Advanced Bitcoin conference. So those graphs are from him. And after this, we discovered that the network has a really good cohesion, even we are not with different network types in this TCP/IP or in onion addresses, they can connect themselves, and having a low latency, a weak cohesion. And Lexa has a consideration. It's interesting to highlight that the half of the network is under the darknet, and they are in the Tor network. There is another topic we need to highlight as well, is about in the end, we are talking about decentralization, but the nodes are under control of internet providers and cloud providers like Amazon, Azure, 25% of the nodes. So this can create a risk. Okay. As conclusion, we have seen that the trilemma of on-chain or trilemma of balance can help us to measure blockchain system, and see if a project can achieve scalability from moving gradually from the other side of the triangle, and see in which place we have to move them, and is fit with our expectation in the user experience. Security is critical. The integrity in information is a must requirement. The data has to be shared across the internet, avoiding to be stolen. Yeah, blockchain approach could not be the solution. Blockchain, we know that the blockchain is trendy, so don't make trend, do over-engineering. And as we see, decentralization is not so decentralized what we can expect. Adoption is important, as many adopted projects can make the ecosystem grow. I has been this is working in Bitcoin. Bitcoin is no blockchain. It's just only the first blockchain company that promote that. We have seen what were the challenges and solutions, and we can apply them in the future and upcoming projects. Questions?